Test coverage in software development is a quality metric that shows how much of an application's code, functionality, or requirements are tested by automated or manual tests. It helps teams understand whether their testing efforts are thorough enough to catch defects early. By measuring what is tested versus what is not, test coverage provides visibility into potential risk areas. An effective introduction to test coverage sets the stage for understanding how it supports reliable and maintainable software. At its core, test coverage answers a simple question: how much of the system is exercised when tests run? This can apply to different levels, such as unit tests, integration tests, and system tests. Higher coverage generally means more parts of the code are executed during testing. However, it does not automatically guarantee better quality without meaningful test design. There are several types of test coverage used in software development. Code coverage is the most common and measures which lines, branches, or conditions in the code are executed by tests. Other forms include requirement coverage, which checks if all requirements have corresponding tests, and functional coverage, which ensures all user-facing features are tested. Each type gives a different perspective on quality. Line coverage measures whether each line of code has been executed at least once during testing. Branch coverage goes a step further by checking whether all decision paths, such as if-else conditions, are tested. Condition coverage focuses on individual logical conditions within a decision. Together, these metrics help teams identify untested logic that could hide defects. Test coverage is especially valuable during early development stages. When developers write tests alongside code, coverage tools can quickly show gaps before they grow into larger problems. This supports practices like test-driven development, where tests guide design and implementation. Early visibility reduces costly rework later in the development cycle. In agile and continuous delivery environments, test coverage supports fast and safe releases. Automated test suites with good coverage give teams confidence to make frequent changes. When new features are added, coverage reports highlight areas needing additional tests. This alignment with rapid iteration makes test coverage a key feedback mechanism. Despite its benefits, test coverage has limitations. A high coverage percentage does not mean tests are effective or that defects are impossible. Poorly written tests may execute code without verifying correct behavior. Teams must balance coverage metrics with test quality and meaningful assertions. Test coverage also plays an important role in managing technical debt. Low coverage in certain modules can signal risky or hard-to-maintain code. By gradually increasing coverage in these areas, teams can refactor with greater confidence. Over time, this really improves code stability and long-term maintainability. Different projects require different coverage targets. Critical systems, such as financial or safety-related software, often demand very high coverage. Less critical applications may accept lower coverage if risks are understood. Setting realistic targets helps teams avoid chasing numbers instead of value. Effective use of test coverage involves continuous monitoring and improvement. Coverage reports should be reviewed regularly and discussed within the team. When coverage drops, it becomes a signal to add or improve tests. Used this way, coverage becomes a learning tool rather than a strict rule. In conclusion, test coverage is a powerful metric that helps teams understand how well their software is tested. It highlights gaps, supports early defect detection, and enables confident change in fast-paced environments. While it should never be the only measure of quality when combined with well-designed tests, test coverage plays a crucial role in delivering reliable and maintainable software.